Hello again, this is Professor Lucine, and this is Lecture 22 for Safety 380, Intro to Occupational Safety and Health. Continuing the discussion of health-related topics, this lecture is going to focus on industrial hygiene and occupational illnesses, toxicology, epidemiology, all that jazz. So, if you're a safety major, there is a course, a 5-credit course, so lecture and lab, dedicated to industrial hygiene. And so I am really going to give you a broad but shallow review of this really important area. I'm also going to talk a little bit about some of the associations you can look to, such as American Industrial Hygiene Association, American Council of Certified Industrial Hygienists, and also I think I talk about the Center for Disease Control and Prevention. I would like you to read Chapter 13 in the Administration and Programs book, and then I've got some other links for you to check out. And as always, use the study sheet to prep for the quiz. Industrial hygiene is similar to safety, but it considers the human exposure to chemicals, biological agents, harmful physical agents, more of a cumulative or chronic exposure of physiological as well. And we typically classify those outcomes as either illnesses or disease. So it's a little bit different than safety. Safety is, I got exposed to something sharp, I got cut. So it's an injury. Or I fell down and I hurt myself and I got a contusion or a sprain or a strain. Industrial hygiene, on the other hand, it's a little bit more investigative. You have to be a little bit more scientific or take a research approach to determine what are workers being exposed to, and is it at a dose that would elicit the illness or other modalities of illness or harm. I guess that's the best I can say it. So basically, you're trying to keep people healthy. I should have just said that, right? There are different areas you can specialize in. I'm more of a generalist. This is how I got into safety, by the way. I talked about this, I think, in my intro video, but my undergraduate degree is in chemical engineering. And I didn't want to be a chemical engineer because I feared I would blow something up. And so I was trying to get into environmental regulation. But OSHA hires from the same list, and then they train you to become an industrial hygiene engineer. And so this is how I cut my teeth in safety. And I loved it. I still love doing it. We have, I think, 4, including myself, industrial hygienists within this department. Myself, Dr. Vosberg, Dr. Ahn, and Dr. Grutzmacher. We're all industrial hygienists. But when I was brought on, I had that side of my background, but I also had the management application side, and they hired me to do the management application side. But also, if those other faculty go on sabbatical or are busy, I could jump in and we wouldn't miss a beat because I've got years and years of practice behind it. So up here you see we're assessing exposures to. Did I say these? I did. Wow, right off the top of my head. I guess I know what I'm talking about, right? But we're also looking at inhalation, infectious, radiation, and biomechanics. So we're really focusing more on how things are entering or affecting the human versus safety. More, we're trying to maybe look for hazards on the outside. More of an environmental assessment versus the person assessment. So that's where, and having both expertise, I think it makes me a double threat when it comes to practicing safety and health. I had talked real briefly about what is an injury and an illness. For me, it's pretty much straightforward. An instantaneous exposure that results in harm is typically an injury. One that usually develops over time tends to be more of an illness. I want you to be familiar with the terms of acute and chronic. So acute is a high concentration, short duration, whereas a chronic is over long periods of time. And the examples I have here on the right is a rash or an allergic reaction, a dermal allergic reaction to an exposure, whereas the bottom, what we're seeing is asbestosis, which is lung cancer due to exposure to asbestos, and typically over a 10 to 25-year career. We're just coming out of a global pandemic due to the SARS-CoV-19 virus. the disease, being COVID-19. And I wanted you to be familiar with the different forms from more of a public health perspective. So on the left, we have endemic. So that shows that the transmissions occur, but there's a number of cases that remains fairly constant. An epidemic is it increases, but in only one locality. A pandemic is when there is a spread throughout the globe. So global pandemic, you have local epidemic, and endemics are pretty much something we have constantly. So I spoke about COVID-19 as it pertains to bloodborne pathogen, OSHA coming up with a temp standard, and the NIOSH or CDC study coming out saying that there's an increase of 16% of fatalities in the U.S. in 2020 due to COVID. But you can also look to groups like the American Industrial Hygiene Association, and NIOSH provides things, and we still use the same approach to assessing potential for exposure, and we should still use the hazard control hierarchy to come up with solutions. Elimination being ideal, PPE being the least ideal and typically the least effective, but usually the easiest to access. And then I've got just another thing up here where it talks about the distancing we heard about, the staying home, the wearing a mask, observing guidelines, because they did change throughout the process. And no matter what your religious or public health or political beliefs are, I'm going to be getting the vaccine. I think it's important for all of us to take advantage. I'm not saying you have to, because there are individual health conditions that are either exacerbated or realized for people who actually get vaccines. That's really the only issue with it. But some people have beliefs. They don't trust it. I can understand that. But as a person who's safety and health, coming up on 30 years experience in this field, this pandemic was very predictable. At a conference 5 years ago, several of us were pulled aside and they were interviewing us, and I think they were just trying to come up with advertising material. And they flat out asked me, what is your biggest concern in safety in the coming years? And I said, the spread of illness, that a serious illness could shut down the globe. That we've been really... Sorry, really? Sorry about that. Suri's questioning me. And they kind of were really questioning, what are you talking about? They thought I was going to say something really simple. And I was talking to another faculty member who was at the conference from a different university in Carolina, and she said the same thing, that this is our biggest concern. And now it's realized this year. And I think what we learn coming out of this process, I think will help us should we ever have to face it again. But again, the last time we had something like this was about 100 years ago with the Spanish flu. Is it going to happen again? Yes, it is. There are going to be variants that happen again. The travel limitation was a joke. You don't just stop international travel. You stop people traveling from town to town. That's how you isolate this. You got to confine. And so therefore what we need to do is better understand our delivery systems to make sure they can flow. So business can still flow, but we can still limit the interactions or keep them limited to small areas. All right, off my soapbox, everybody. Here are the 4 different routes of exposure that we have to assess. Inhalation is primary. That's pretty much straightforward. Dermal, that can either be something that actually absorbs through the skin or could possibly make its way through skin that is not intact. Ingestion, and ingestion can be actually associated with an inhalation as well, especially since we have a natural filtration system that when we breathe something in, it tends to be for particulate, not aerosols or gases or vapors, but it'll impact the back of our throat or our upper esophagus, and we've got little hairs in there, and the hairs are coated with saliva and sputum and, lack of a better term, snot, and it impacts that and doesn't get into our lungs. And then we either expectorate that material or we ingest it. And so sometimes things that actually, are protecting us from not breathing it in, we get ingested. Injection, whether it's A needle stick, an incidental needle stick, or a mosquito or something else, that's another way to get in. The terms that I want you to be familiar with from a toxicological perspective would be dose, because you don't just say, oh, this is poisonous. It's the dose that dictates the poison. If you consume too much water, it can kill you. It can. I've heard of people running like a marathon on a super hot day, and they just drink water and all kinds of water and all kinds of water. It imbalances their. We have a delicate balance of minerals and electrolytes in our body, and if it gets depleted, the body can't function very well. It has difficulty regulating muscle control, heat, or I should say our core temperature, and I've seen people hospitalized, pretty close to death actually. Toxicity, the ability to produce an unwanted effect. There are usually target organs, which is one way that if we know how something enters the body, what organ it attacks. Sometimes when we just get symptoms from somebody, we have the ability to go, I think it's this, and now I can go test for it. Versus a complete, floor to ceiling search. I should also let you know, and I'm also going to say it in a little bit, there is no one device that you can walk into a room and go and know what it is and what the exposure is. That does not exist. Only in Star Trek does that exist, or Doctor Who. It does not happen in real life. You have to know what the thing is. You have to have the right equipment. You have to pre-calibrate, post-calibrate, and there may be some lab work that has to occur in which they run a sample through an IR spec or some other thing that tells you what's there, how much, and then based on how much you collected or how long you were there, you have to estimate things like that. So there's a lot of math and physics calculations and chemistry calculations in this field. Finally, you have to also know detoxification, how the body processes it. Sometimes it actually biotransforms certain chemicals into something either more hazardous, we hope less hazardous, and then how the body expels it as well. The difference between toxicology and epidemiology. Toxicologists usually do controlled laboratory experiments in which they take a lab animal, whether it's worms, mice, rats, and they expose half of the population or to a chemical, or they create different groups and they expose them at different levels. And then they will look and see how it harmed them. But I know I've been reading more and more now. They're coming up with human system simulators in which they allows them to test on these artificial human systems without harming animals or anything like that. So that's on the horizon too. That's pretty cool. But what they're just trying, because there's terms like LD50, lethal dose 50. So at what concentration I shouldn't say what concentration, at what dose per body weight of the test subject did it kill 50% or more of the group of animals? Epidemiology, on the other hand, is the study of an occurrence in the real world. So epidemiologists are studying the COVID. If some chemical gets released into the environment or into a water system, they will study that. So it's real world studying. So epidemiology is much more sophisticated than toxicology. Toxicology, you're in a lab, everything's controlled. It's a lot easier to be a toxicologist than it is to be an epidemiologist. Epidemiology, you've got all kinds of confounding issues you have to deal with in doing your studies, but it's more aligned with, okay, now we really know how this affects humans, versus toxicology, we have to do like a stratification or an extrapolation of what the lab data says. Interestingly enough, the dose response is typically not a straight line. There's usually maybe, and sometimes it goes the other way, it curves the other way, that you can be exposed to some of it, nothing ever happens. And then maybe there's little signs, and then maybe it gets bad at one point, but then it may trail off. It depends on the chemical, it depends on how the body reacts to it, whether it's processing it and expelling it, or whether there's a bioaccumulation. There's a lot of sophisticated things, but they try to create that dose response curve for others to extrapolate from. AIHA is the American Industrial Hygiene Association. This is a member organization, I believe, yes. Yeah, because I think the American Council of Certified Industrial Hygienists has become a different type of entity, like an educational entity. Because industrial hygiene is not my primary, I am currently not a member, but I do keep up my license as a certified industrial hygienist. So let's go. Let's look at some of the equipment that we use. The most familiar might be carbon monoxide, especially in the northern states. In the wintertime, we have deaths, usually in the home, associated with carbon monoxide. Carbon monoxide is an incomplete oxidation of a carbon molecule. Carbon dioxide is the fully oxidized phase. Carbon monoxide, therefore, is flammable. But here's the issue with it in humans it readily attaches to our red blood cells, actually more readily than oxygen does. So if you are in an environment with carbon monoxide, 100 parts per million or more, you're breathing it in, and what it's doing is it's limiting oxygen to your body. Initial symptoms would be nausea or stomach ache, especially if that's where the blood's trying to go. Difficulty breathing, cough, headache, confusion. These are the early signs of somebody asphyxiating or suffocating, if you want. And so if you get enough in your body isn't moving oxygen around like it should, so the body starts shutting down. And that's how you die from carbon monoxide. We do process it and expel it, but they tend to treat you in a oxygen rich environment to try to return you back to status quicker. It basically comes from burning carbon. So like a powered industrial truck, fork truck, running on liquid petroleum or LP, the exhaust pipe may be giving off 10,000 parts per million. So if you're in an enclosed area and that thing is maybe running dirty, that room or that space could fill with carbon monoxide very quickly. Your furnace, if it's natural gas, can give off carbon monoxide. Anything that's gas burning can. So that's why they always warn that if people are gonna, if you're gonna warm your house, don't warm your house with something that burns, unless you have proper exhaust. So how do we monitor? Well, up on the right, there's a $30. I forget what those things are called. It's just a carbon monoxide detector. I think in Wisconsin, if you're in an apartment, you're supposed to have carbon monoxide detectors provided by your landlord. They should let you know when levels are getting dangerous. And the level of dangerous is 25 parts per million. So essentially 1/4 of what an 8-hour exposure should be. I think that's right. Or maybe it's 1/2. I think IDLH for carbon monoxide is like 1,000 or something like that. You can look that up. IDLH is immediate death or to immediate danger to life or health. So that's about $30. Should have it. You should change it out frequently because the titanium sensor can go bad. It also falsely reads carbon monoxide as hydrogen, or falsely reads hydrogen as carbon monoxide. So don't charge batteries near a CO detector because it'll pick up the hydrogen and think it's carbon monoxide. Over on the left, these are constant monitoring clips. You just put it on the worker and they put it and it logs the information throughout the day. At the end of the shift, you plug it in the computer, you download it, and you got it. In the middle, we have a 4-gas or a 3-gas meter. These are typically used for confined space entry, but they do monitor for carbon monoxide along with hydrogen sulfide, lower explosive level, and oxygen. Over on the right, that's a passive dosimetry badge. This is something that you wear and it lets you know over a shift. So it's passive. So it's cheaper. I mean, they're $17 a shot compared to the others, but you can clip it on the person and then it kind of tells you at the end of the day approximately what the person was exposed to throughout the day. I don't prefer the passive dosimetry, even though it's cheapest. I'd rather use detector tubes and then actually just rent the constant monitoring ones because you can use them throughout. Another thing we do is we monitor noise. So here's some things we have. Bottom right are sound level meters. So this is just for walking around to get an idea of what's producing the most amount of noise. Some of them have data logging capabilities. Some you can actually fluctuate the, what do they call that? Not the range, the wavelength? Is that what it is? Or the frequency? Frequency modulation, that's right. Because different frequencies affect your hearing differently. We'll cover that next lecture. On the left, we have equipment that you actually put on the worker, and then you put the microphone within 6 inches of the ear, and then they wear it all day, and it monitors all the different noise levels they're exposed to and data logs it, and then you can download it. Oh, one thing I note on here is whenever you do any form of whether it's air monitoring, noise monitoring, heat stress, it needs to either be conducted by or supervised by someone who holds the license of a certified industrial hygienist because they have to sign off on it because it's a medical record. We had talked about medical records earlier in the semester. The employer must keep that, I think, for 20 years or 25 years. The workers need to be informed on what they are exposed to. That's one of their rights under the OSH Act. But if you don't have someone who holds that license, it's not considered valid. So you're just gonna have to redo it and have someone with it do it. Here is air monitoring equipment. Different versions of it. So up on the right, I think that's a TLV sniffer. What this does is it's got a wand and it's got a pump in it, an air pump. And so it's pulling air from wherever you point the wand and it gives you a reading of what it's looking at. I think there's like an EV tester as well. You can set the electron volt reading to different types of air contaminants and it can monitor it. I've used particulate counters. You just set, what you want the aerodynamic diameter to be for the particulate. The one that looks like that has the piston pump with all the different colored tubes, that's a dosimeter pump. That's a piston. And what you do is, and I used to pack my bag when I was a compliance officer with a whole variety. I usually carry about a pack of 20 different, and it allows you just break the two glass ends very carefully, by the way. And then you drag, they call it, 5 to 10 times depending on what the instructions are, and it gives you an immediate colorimetric change on the tube itself to let you know what the air level is. So it's inexpensive, and it allows you to go to the next level. Should I come back and do full shift sampling, or should I go get equipment that's more sophisticated? The bottom pictures, the bottom left are the different types of pumps. They're usually low and high flow pumps, 2 liters per minute down to like 0.25 liters per minute. And the column looking things in the middle there are called calibrators or bubble. What did we call them? Gillibrators, because they're made by Gillian, I guess. And so what you do is after charging your equipment, you pre-calibrate before you go out to collect. And then you post-calibrate too, because you're going to have to submit, like over on the right on the bottom, those are charcoal tubes. And so they will collect organic material, organic vapors. And you submit to the lab breaks them open, they test and they tell you what's the quantity there. And then you divide that by the volume of air you pulled through it. So the pump has a certain rate, you have a certain time they wore it for, and that's the volume of air, and then you determine sort of the concentration from that. So it doesn't detect highs and lows. It's more of an overall average. This is for testing airflow and heat stress. So on the bottom left, that's actually a heat stress monitor. It detects dry bulb, wet bulb, and globe temperature, which is radiant heat. The middle is it's a nunchuck. No, it's a sling psychrometer. What you do is you dampen the wick, and then you swing it around for a certain amount of time, and then it tells you the wet bulb and wet bulb, dry bulb temperature, and you can determine the humidity based on that. Over on the right, we have a velometer. The one on the bottom is a hot wire anemometer. The one on the top is a repeller. Hot wire anemometer, basically, as air flows over this heated wire, the rate in which it cools it is transitioned into or turned into a velocity. Here are additional resources that I've already mentioned and will provide you on the Canvas site. So I gave you a very broad overview of something I really enjoy doing. IH, I think, is really fun. And if you're in this profession, I hope you enjoy the class. Doing hands-on work, it's almost like you're an investigator, and it's pretty cool. I've seen some pretty wild things. It requires you to be very flexible with your schedule. I've done air sampling from 2 a.m. on a Sunday to, Monday at midnight. It's weird hours, but when you put in those really long shifts, I don't know, it's just really enjoyable. You do get time for yourself, and everything is so, scientific with how you do things and keeping track of things and then doing the calculations. I that's just a side of me that I don't always get to exercise. So I enjoy doing IH work. So check out chapter 13. Check out the links I provided. And as always, the study sheet is meant to prepare you for the quiz.